Good afternoon, grade 12s. Welcome to Technical Mathematics. Today we are going to be discussing financial mathematics. And then you should also remember that we did financial mathematics in grade 11, but it's going to be part of final exam. So we really need to revise this topic. And then also you should look into examination guideline. What are they saying about the financial mathematics? What are the things that you need to understand before you go and write your final exam? And then also we should remember this topic is part of paper one, uh, and it's one of the topic that learners they can score a lot of marks in this topic. All right, let's start and see what are we going to be discussing for today's lesson. All right, under content we have financial mathematics, which contributes 15 plus or minus 3 marks in paper one out of 150. And then under financial maths, things that needs to be revised. One is use simple and compound growth and decay formulae. And then we also have to look into straight line depreciation and depreciation on reducing balance method. And remember this one is the same as decayed formula. Is decayed formula. Then, but we'll explain that into details later. And then the last one, of course, is nominal and effective interest rate. So these are three concepts that needs to be revised thoroughly, so to prepare ourselves for this coming final examination. Uh, but everything is going to be fine if we just have to make sure that we prepare ourselves in everything that we have touched in grade 11, actually from grade 10, whatever that we did under financial, make sure that you revise it so that when you enter to the exam room that you are prepared for that paper for technical mathematics. And also is much better if you use the previous question papers and look how did they ask financial questions, and then I think that will be much better. All right, let's start and see what are we going to have. All right, then we'll start with the simple interest formula. As we know that the simple is equals to A equals to P into 1 plus IN, where A is the final amount and P is the present amount or the starting value. I is the interest rate, and then N is the number of time period. And then we also go to compound interest, which is A equals to P into 1 plus I to the power of N, where A is final amount, P is the present amount, and then I, of course, is the interest rate. And then remember, every time when you are dealing with I, you first start with dividing with 100 before you can substitute to the formula. Then N is the still number of time period. And then under compound interest, we've got different compound periods that needs to be known. And then we have monthly, weekly, daily, semi-annually or half-yearly, quarterly, and annually. So for monthly, we are going to be using 12. Weekly is 52. Daily is 365, and semi-annually, or sometimes they say half-yearly, is 2, and quarterly 4, and then annually 1. Then by the time we are going to be answering questions, then we'll be using these values there. And then I hope you are going to be you're going to be able to see on how do we apply those values. For instance, we have monthly is 12, and then what are we going to do with that 12? Let's start with the simple and compound interest. and try to answer questions and see on how do we apply this one. And then it says Sibongile invest 4,600 for 4 years at 10% per annum simple interest. Thereafter, she invests the accumulated amount for another 2 years at 12% per annum compounded interest. Calculate how much money she will have saved at the end of the 6-year period. Now you can read from the scenario that we are having simple interest and the compound interest. Then we are going to be using both the formula to calculate the final amount. And then the other thing that is it will help you is when you have to write the data, write what we have from the scenario so that you can be able to see what you don't have, and then it will simplify things for you to calculate. All right. Of course, we can see the money invested is our P, and then I, which is 10%, and then we have another 12% again. But first, the first 4 years, we have to calculate for the first 4 years using the simple interest formula, and then we substitute the value of P, which is the initial amount which was invested by Sibongile, which is 4,600, into 1 plus 0.10 times 4, and then you just press your calculator. There it's going to give us 6,440,000, and that is the amount of money for the first 4 years. And then it says, therefore, thereafter, she then invests the accumulated amount for another 2 years at 12% compounded, per annum compounded interest. Now, this is accumulated amount after 4 years. Then we are going to continue with it. We invest it again for another 2 years, but now it is in compound interest. Let's see. The remaining 2 years, you write the formula for the compound, and then you substitute the money that we accumulated after 4 years, which is now going to be our P, 6,440 rand, and then 1 plus 0.12, because I clearly said we should divide our interest rate with 100 before you substitute it to the formula. And then to the power of 2, then you press your calculator, then we are now having 8,078.34. That is the amount of money after 6-year period. 6-year period. That's how we should now calculate the simple interest and the compound interest. Compound interest of changing interest rates. Now, let's see when we are calculating using the compound interest, and then in the same scenario, we've got more than one interest rate. The interest rate changes. Then how do we approach that question? Let's read. Mohau deposited 60,000 into a saving account. The financial institution offers an interest rate of 14% per annum, compounded semi-annually for the first 3 years. Thereafter, the interest changes to 16% per annum, compounded monthly. Mohau decided to leave the money into saving account for 4 more years. Calculate how much investment money Mohau will have at the end of 7 years period. Now let's see. Now first, it will be much easier if we answer this question using the timeline. It's going to be much better. Let's make sure that we write this into timeline. Let's see on how do we draw the timeline. Now remember, the total number of years is 7 years, right? And then you will see that we have from T1 to T7, which is 7 years. That money should be invested into saving account, or should be deposited into saving account. And then the initial, remember, it was 60,000. That's what money was deposited. And then it says the financial institution offers interest rate of 14% per annum compounded semi-annually for the first 3 years, meaning 1, 2, 3. For the first 3 years, this first 3 years, the interest rate was 14%, right? Was 14%. And then it says thereafter the interest rate changes to 16% per annum compounded monthly, meaning for the remaining years. Mohau decide to leave the money in saving account for 4 years, for 4 more years. Calculate how much money you save. Meaning from here up to the last year, now the interest changes to 16% now. So how do we tackle this question? How do we answer this question? Let's see. This is what you should now write. You start writing the formula for compound interest, then you substitute the money. P is the initial amount that was deposited, which is 60%. I mean 60,000. 60,000. And now we first have to have the first bracket. Let me just explain. You say 1 plus, now the first, we have to calculate from year up to the 3rd year. Now, because the interest is not the same, and we have to get the interest first year. So it's 0, 0, 0,14 over 2. Why 2? Because it was compounded semi-annually, and we agreed earlier on that semi-annually is 2, then we divide with 2, and then it's 3 years. 3 times 2 is 6. Hence we have 6 in this one. And then multiply by another interest rate, which is 16%. So we say plus 1 plus 0,16 over 12. Why 12? Because this interest is compounded what? Monthly. Then we agreed monthly is 12. And then how many years do we have from there? We have 4. So 4 times 12, and then it gives us 48. Then from there, you just put everything on your calculator, and then you just press your calculator. Then you will get 170,045 rand 72 cents. That's the amount of money that you are going to be getting after 7 years. All right. Simple interest and compound interest. Let's see. All right, we have another scenario. Let's now read and understand what are we going to be calculating. It says Motor invests a certain amount of money for 6 years at 18% per annum compounded quarterly for the first 3 years, and 13% per annum compounded monthly for the remaining term. The future value of the investment at the end of the 6-year period is 25,000. How much did Motor originally invest? Now it's very clear from this scenario that we don't have, or we don't know the money which was invested at first, and then we have the final amount, which is 25,000. And then I always advise learners that it's much better if you write your data down so that you can be able to see what you have and what you don't have, so that then it's going to be easy for you. Now, since we've got more than one interest rate, and then we are going to be using what? Timeline to answer this question. All right. Let's see, we're going to start with the timeline, and then you write the number of years, and then I think the number of years is 6 years, right? So we're going to have 6 years, and I think it's supposed to be how much? Yeah, it's going to be 6 years. So meaning this one is out. This one is out because it's supposed to be 6 years, right? It's from T0 to T6 because it says 6 years. And then this amount of money, which is 25,000, supposed to come under this T6 because it's 6 years, right? And then that is the final amount that we have obtained. So we want to understand, or we want to calculate how much Motor invested. We want to know that one. Now let's see on how do we calculate that. First, we write the compound interest formula, and thereafter you then substitute the values, because now remember P is the initial amount, is the money which was invested. So that's what we are looking for. So we are in need of P in this case, and then the value of A is 25,000, of course. And then now what is happening? Let's go and understand our scenario first. It says 6 years at 18% compounded quarterly for the first 3 years, and 13% per annum compounded monthly for the remaining term. Now we first have 3 years, 1 up to this is going to be 3 years, and then from here it's how much? It's how many years? 1, 2, 3, 4. So this is 4 years, right? The first 3 years is 18%. So this is going to be the 18% for first 3 years. And then for the remaining years, I think it's going to be 4 years. And then the interest rate now is 13%. All right, it's 13%. Okay, now when we are in need of P, and then when we calculate, we are going to be calculating from right to left. From this T6, then we take this direction, because now we want this amount here, the amount that Motor invests, we want that amount. So then we'll be calculating from right to left, right? Now, let me start explaining this first bracket, and so that we can understand what happened. Then we say 1 plus. Now, since I said that we calculate from right to left, then it's going to be 1 plus 0.13, which is this interest rate, which is 13% over 12. Why 12? Because it was very clear from the scenario that is compounded monthly, and we agreed earlier on that monthly is 12. And then because from T6 to T3 is 4 years, then we're going to be multiply 12 times 4, then it's going to give us 48. And then we have another bracket, because now we are going to be dealing with another interest rate, which is 18%. Then you're going to say 1 plus 0.18 over 4. Why 4? Because it's compounded quarterly, and we said quarterly is 4. And then how many years from T3 to T0 is 3 years, right? It's 3 years, so 3 times 4, it gives us 12. Now, I think everything is fine. So now since we're in need of P, we are going to be dividing both sides with these 2 brackets, and let's do that exactly. We divide both sides with these 2 brackets, and this is what we're going to be having. Then after having this, you just put everything inside your calculator, and then you say equal sign, then it's going to give us 8,788 rand 73 cents. So that is the amount of money which was invested, Motor invest, for her to obtain 25,000 after 6 years. All right. Then remember I said this T7 is out because it was supposed to be 6 years, not 7 years. All right. That's how you should now calculate the value of P. Now let's proceed. All right, we are having another scenario. It say the peer invest 55,000 into the saving account. However, after 2 years, she withdraw 10,000 to cover for siblings' school fees. 7 years later, she withdraw a further 20,000 to pay off her car loan. The interest is constant at 15% per annum compounded monthly. How much can the peer withdraw after 10 years? So now in this one, we also have to use the timeline because you can see we have withdrawals. We have got, I think it's only the withdrawal in this one. We don't have any deposit. So we need to be able to calculate the final amount after investing 55,000. Now let's see on how do we calculate this one. We start with the timeline because now it's 10 years. Then it must be 10 years. Let's see, this is 10 from T0 to T10 because T is 10 years. And then the initial amount which was invested was 55,000. And then it says, however, after 2 years, she withdraw. It means after 2 years, 10,000 was withdrawn from the account. And then further, 7 years later, she withdraw a further 20,000. This is 20,000 after 7 years. And then let's calculate how much the bill will withdraw after 10 years. So we want to know after 10 years, how much money will be in her account. First, you write the correct formula for the compound interest. And then from there, you substitute the values. Let me start with the first bracket and then let me just try to explain. P is the initial amount, the money which was invested, which is 55,000. And then the first bracket, it's a 1 plus 0, 0,15. Now, because the interest is the same throughout, we have got the same interest throughout, which is 15%. All right, then we're going to be using 15% throughout. Now, we want to check, it says 0,15 over 12. Why 12? Because it was very clear per annum compounded what? Monthly. And we said monthly is 12. And then from T0 to T10, how many years is 10 years? So it's going to be 10 times 12, then it gives us 120 years, right? It's 120, not years, but a month, 120 months, because it's a compounded monthly. So meaning the interest is going to be generated after every month, right? And then from there, from 10 T2, which is after 2 years, she withdraw 10,000. Hence, you see negative because this 10,000 was out of the account. Well, all right. And then you also have to multiply it with the interest rate, which is 1 plus 0,15 over 12. Y84 is from this T2 to T10, right? To T10. So you say 12 times, I think it's 7. Let's see if that is correct. Let's calculate from T2 how much. It's 7 years. So you just multiply the 7 years times 12, give us 84. And then after 7 years, she then withdraw 20,000 again, which is minus. You can see this minus. If it was deposit, then you just use addition. But now since it's withdrawing the money, then it's negative 20,000. 1 plus 0,15 over 12. Then from T7 to T10, is 3 years, so 3 times 12 is 36. Then after this, you just put everything on your calculator, and then you press equal sign, then it's going to give us 184,541 rand 72 cents. So that is the amount of money De Beer will get after 10 years. All right, now let's start with this scenario and see on how do we go about this one. Hlakwani invested 75,000 into an account that offers interest at 8.2% per annum compounded quarterly for the first 18 months. Thereafter, the interest changes to 6.5% per annum compounded monthly. 3 years after the 3 years after the initial investment, 5,500 is withdrawn from the account. A year later, after the withdrawal, 6,000 is deposited into account. How much will be in her account at the end of 7 years? Now you can see from this scenario that we've got more than one interest rate, and then we also have the withdrawals and the deposit. Then let's see on how do we tackle this question. And it's also need to draw your timeline and put everything on the timeline so that you can be able to see on how do you start or where do you start. I mean, let's see timeline. And then how many years is 5 years? This one is 5 years. You just write from T0 to T5 because it's 5 years. And then remember 75,000, it was the initial amount which it was invested into the account. And then this 5,500, what happened? 3 years after the initial, meaning 3 years from this to this, the money was taken out from the account. And then a year later, she then, after the withdrawal, 6,000 deposited. And the year later from this one, then she then deposits 6,000 into the account. All right, and then let's go to the interest rate. It says 8.2% per annum compounded quarterly for the first 18 months. Now, since we are working in terms of years, then we'll have to convert this 18 months to years by saying 18 divided by 12. Then it's going to give us 1.5, meaning it's 1 year and 6 months. So it's here 1.5 is somewhere here, meaning from this, let me just remove this one first. All right, let me just remove this. For the first 18 month, from this one to this, the interest rate is 8.2%. That is the interest. And thereafter, the interest rate changes to 6.5% per annum compounded monthly, 3 years after the initial investment, meaning for the remaining years, the interest changes to 6.5%. All right, at least on this one, you've got different types of interest rate, and then also we have the withdrawals and the deposit. Let's see on how do we calculate this one. You first write the correct formula for the compound interest, and then from there you subtract everything. Let me explain every step. And then remember, 75,000 was invested, which is the initial amount. So it's our P, which is this one, and then 1 plus 0.082. Remember, I said the interest rate you divide with 100. then it's going to give us 0.028 over 4. Now, why 4? Because this 0.8%, it was compounded quarterly, and we said quarterly is 4, then this is 4. And then 6, how did we obtain 6? From T0 to 1.5, meaning we said 1.5 times 4, it gives us 6. Then from there, we have another bracket, because now we have to calculate from this 1.5 to the last year, which is 5 years. And then we say 1 plus 0.065, because the interest now changes to 6.5 divided by 12. Why 12? Because this 6.5, it was compounded monthly, hence we used 12. And then how many years from this to the last year? I think it's 1, 2, 3, 5, meaning it's 3.5, then it's 3.5 times 12, then it gives us 42. And then later, I think it say 3 years after the initial investment, 5,500 is withdrawn from the account. 3 years. Now from here up to this, the money was taken out from the account, which is 5,500. Hence you see negative 1 plus now 0.065, because this we can see it falls on this interest rate, which is 6.5. Then hence we're using 6.065 over 12. And then from this to this one, and then it's 2 years. So it's 2 times 12, you get 24. And then year later, after the withdrawal, 6,000 is deposited into account. Hence you see positive there. Positive 6,000 plus 1, 0.065 over 12. From T4 to T1 is 1 year. So it's 1 times 12, then you get 12. Thereafter, you just put everything on your calculator, and then you press a calculator, then you get 106,426.14. So this amount of money Hlakoni will get after 5 years. All right. Brenda, I deposit 5,500 into saving account. 5 years later, 4,000 is added to a saving account, and the interest rate for the first 3 years is 14% per annum compounded semi-annually. Thereafter, the interest rate changes to 12% per annum compounded monthly. Calculate the future value of the savings at the end of the seventh year. Let's see how do we do the timeline. Is very important. How many years? 7 years. Is from T0 to T7. And then what was the initial amount? It was 5,500. And then I think 5 years later, 4,000 was added, was deposited, right? And also you have different types of interest rate, which is 14% and 12%. The interest rate for the first 3 years is 14%. So from this to this is 14%. From T3, and I think the remaining years is 12%. And then from there, you write the correct formula for the compound interest. And then you then substitute. P is the initial amount deposited, which is 5,500. The first bracket is from T0 to T3. Interest rate is 0.14 over 2. Why 2? Because it's compounded semi-annually. And then from T0 to T3 is how many years? 3 years. 3 times 2 is 6. And then another interest rate, which is 12%, is 1 plus 0.12 over 12, because it's compounded monthly. how many years from this one? I think is 4. 4 times 12 is 48. Then plus, because this money was added to the savings, which is 4,000, open 1 plus 0.12 over 12. From this T5 to T, this is, I think, is 2 years. 2 times 12 is 24. Then just put everything on your calculator. Then it's going to give us, let's see, 18,386 and 28 cents. That is the amount of money Brenda will accumulate after 7 years. A straight line depreciation and then reducing balance method. This is the straight line method and the reducing balance method. So this two, the first one, let me start with the first one, is the same as simple interest. The only thing which is the difference, I think, is negative, because that one we use positive. You can see this negative. The same applies with reducing balance. You must think of compound interest, but now we are having what? A negative there. The money, then the value of P, Q, PA, PI, and N are the same with reducing balance, the same thing. Final amount, present amount, the interest rate in terms of percentage, the number of time period. How long, let me start with how long will it take an investment to halve? Let me just underline that. To halve the investment if it depreciates at rate of 12.5% per annum compounded on the straight line method. Now remember, when we are dealing with the reducing balance method, or the let me just say decay, all right, decay or depreciation. When you are dealing with depreciation, we are dealing with items that are losing values, right? And then you will find that P is always bigger than A, because the initial amount is going to be more than the final amount, because it depreciates, right? For instance, if you buy a car this year with 10,000, how much car will cost after 5 years? The car is going to cost less than what is costing now, right? So it's depreciating. So every time when you're dealing with depreciation questions, you'll find that P is more than A. It's bigger than A. So that's how it's supposed to be. Now in this one, they say we should use the straight line method. Let's see on how do we do that. The straight line formula is that, and then now the amount which was invested, we don't know it. So it say to halve in value of depreciate, meaning it was 2x, then the half of 2x is x, which is the final amount. 1 minus 0.125 n, meaning we're in need of n. We want to know how long. Then from there, you're going to divide both sides with 2x. And then when you divide with 2x, then you're going to give us 1/2. And then from there, you're going to transpose this positive 1 to the right hand side. Then it's going to be -1. And thereafter, you divide with negative, then you are going to have 0.125 n equals to 0.5. Then you divide with 0.125, then it's give us 4 years. Number of years is 4 years. Number 2, if investment of 95,000 depreciate at 6.5% per annum using the straight line depreciation, determine the value of investment after 3 years. You write the formula for depreciation, and then you start substitute the value, because this is investment. The money was invested, which is 95,000. Let's see, and then after 3 years, then we have 76,475 rand. So this amount after 3 years, the money depreciates at 6.5%. A car costing 85,000 depreciate at the rate of 12% per annum for 3 years using the reducing balance method. Determine the amount of the car after 3 years. Let's see on how do we calculate that. You write the reducing balance method, you substitute the value, and then after 3 years, this car will cost now 57,925 rand and 12 cents. Now from 85, now this car after 3 years, it will cost how much? 57,925 rand 12 cents. So it depreciates. All right. Let's see. Now determine the rate of depreciation that will be used if a car depreciates from 120,000 to 63,320 cents in a period of 5 years on a reducing balance. You write the correct formula. The value of A is always smaller than P. You can see this one. Then from there, this is what you're going to be dividing first with 120,000. This is what we did. We divide with that, and then we are having this. Now, because we are in need of I, then we need to get rid of this exponent 3. Then hence we multiply that 3 with 1 over 3. And what we did on the left-hand side, we should also do on the right-hand side, which is 1 over 3. And then from there, and this side we are left with 1 minus I, and this side you just press your calculator and 0.80. And then remember, you write after pressing calculator there, you will write everything that you see on the calculator. Don't try to round off answer before you reach to the final answer. Write everything, then you will only start rounding off when you reach the final stage. You transpose -1 this side, this +1 this side is going to be -1. Thereafter you divide with negative, then it's going to give us I as 0.191889389. Then from there you take it to percentage, then you just multiply with 100, then give us 19.19%. The nominal interest rate is the rate that is coded into equation. The effective interest rate is equivalent annual interest rate that will receive once compound has been taken into account. In order to compare the interest rate with the different compound period, it is often useful to convert nominal rates into effective rates, or nominal and effective. And then the nominal and effective formula that we're using is this one. So if we are in need of nominal effective rate, we are going to make this the subject of formula. So let me just remove this. All right, and then they are saying, all right, sorry. All right. I effective, which is effective interest rate. You can see that one. Let me just explain. All right, thank you very much. I effective is the effective rate, and then I norm is the nominal interest rate, and then M is the number of time here the nominal rate is compounded, right? It does not stand for the number of years, but it stands for the compounded period. Then let's see the question on how do we answer this question. Convert an interest rate of 15% compounded monthly to effective interest rate. Let's see on how do we do that. You write the correct formula for that. You then substitute the nominal rate, which is 15%. Then you divide with 100. It's going to give us 0.15 over 12, because it's compounded monthly. It's 12, and then also here's 12. And you transpose this one to the right hand side is -1. You press the calculator. This is what we are having. You multiply by 100 to get the interest rate, which is 16.08%. Another question, convert an interest rate of 8.25% per annum compounded quarterly to an effective interest rate. Let's see. You then substitute because it's compounded quarterly, hence you see 4 there. and then you transpose that 1, and this is what you're going to be getting. And then now you're going to multiply that with 100, then it's going to give us the interest rate as 8.51%. All right, thank you very much, learners. I hope whatever we have discussed on this lesson is going to help you to prepare yourself for the final exam. And then now, before I can leave you, I just want to leave you with this words that says, never give up. Today is hard, tomorrow will be worse, but the day after tomorrow will be sunshine. All right? So let us not give up. Thank you very much. Have a nice evening. Bye.